In this section, I'll talk to you about creating a surface finish block. I'll give the layer command, and in the layer list, I want to create a new layer. Call it dimension. Keep it continuous, and the thickness, keep it to be thin, 0.09. And now create the symbol. So line, snap to the middle of this. And I want to go like that, 5 millimeters at 120 degrees. So it will be at 5 less than 120. And enter. And click enter again to repeat the last given command. Click to snap here, and I want to go like this for only 60 degrees, but with a 10 millimeter length. So at 10 less than 60, enter, and enter again to finish creating the symbol here. Let me now put the symbol on the proper layer here, on the dimension layer. Now I want to create an attribute for the value of the surface finish here. So I'll type in the command ATTDEF and enter. And the window will appear with the attribute definition here. And I need to give it a tag. I can say value, short for val, and the prompt should be please give surface finish value. The default can be set at 3.2. We can set the justification to be center. We'll set the text height to be 6. And we'll click OK. And I have the value here. I can place it on my symbol. Click. Actually, I'll set the text height to be 3. Click OK. And it's much better now. I can move this around to adjust the positioning. Now we can give the block command. And here we have to type a name for the block. So surface block. We need the base point. So pick the point. This will be the base point. We also need to select the objects. And we have to select here the 2 lines and also the attribute, like that. Tap enter. And you can see a preview here. Click OK. And now, as you can see, it asks for the value. Let's give it 1.6 and enter. Click OK. And it set it here. Now if we go and insert a block, so we have here the insert, and we have our surface block here, and we can insert it somewhere like here, and it will ask us for the value 6.3 and OK. And as you can see, this is very practical because you don't have to draw this every time in order to place your surface finish values on the drawing. By creating this surface block here, I not only made a symbol that I can use, but I also created a command called surface block. So if I type in surface block from the keyboard and tap enter, you can see that the block automatically snaps to my cursor and I can place it somewhere. So for example, near this surface here. And now once I click, it asks me for the scale. So if I don't want to change the scale, as you can see, I have in braces 1, so I'll leave it that. So tap enter. That was for the scale of the X, and enter again for the scale of the Y. And now I can also rotate this around if I want to. If I don't, I'll just tap enter again. And it will ask me for the value that I want to place. If I want the default, all I have to do is click OK. And as you can see, the block placed the symbol and the value that I chose here alongside these other examples. This is the part we are working with today, and it has several types of holes that can't be seen only if we look from the top or only if we look from the side. So that means that we have to draw a section view so that we can see the type of hole. Like here we have a countersunk, and in the other part we have a counter bore. And we have to create what is called an aligned section view. Basically, we have the part and we have to split it into two with the help of two planes. And these planes have a common intersection point in the center of the part here. And we remove one of the halves of the part, and the other half we consider for projection in the front view. While in the top view, we'll consider this projection from this direction, and we'll have to create a trace for the cutting planes as well. Examining the part with the dimensions turned on, we can see that the detail requires many dimensions to be considered, even though the part is not very complex. And we have here an angle that signifies the angle between the axis line for the vertical plane and the inclined axis line for this rest of the part, where the origin is in the center of the part. So when we start to draw this, we'll have to create an axis line, which is straight, horizontal, and then another one, which is at 60 degrees from the vertical axis line. And after that, we can start working on the top view. After finishing the top view, we can create our section view in the front. So I'll start my drawing by considering a few layers and positioning my axis lines. Because I don't have an overall dimension for this due to the shape, I have to first draw the axis lines and build the part, the projection on based on the axis line positions. So first of all, I'll give the line command, MID command to snap to the middle here, then perpendicular to go perpendicular here, and another line from here towards the top, go perpendicular there, extend it downward. Okay. So I'm working on the axis layer. I need to have this visible. So LT scale. Let's try 7. 10. Okay. So I have my two axis lines which will help me to draw the projections of these cylinders. And now I need to draw this axis line here at a 60-degree angle. So a 60-degree angle like that. If my computer calculates the angle from here, I have 180 and another 30, so 210. So I'll give the line command, click here to snap, and then the add symbol. Give it a 100 millimeters. Less than sign, and 210. And now if I check, I should have here 60 degrees. So DIM ANG for angle. And even though I'm not, I have not styled yet the dimensions, I still have possibility to look. It's 60, so I'm working properly. I was missing a dimension, but now I placed it between the axis line here and the axis line for these cylinders here. We have a dimension of 50 millimeters. So if I place my coordinate system, UCS, enter, M, enter, click here, I can draw that line, that axis line. And if this has a radius of 15, that means the axis line should be 30, but with the extra dimension, it needs to be 36. So I have to draw a 36 millimeter axis here at 50 from the left. So at 50 towards the right. So line 50, comma, minus 18 at 0, comma, 36, and enter. The other cylinder is also at 50 from the vertical here, actually from here towards the angled line. We have a 50 millimeter axis distance from the origin towards the axis. So we can rotate this one. So rotate this, rotate, enter, click, and the base point will be the intersection here, and the angle will be 210. And I also needed to create a copy, so let's Control Z, rotate, click on the axis line, enter, click on the origin point, the base point, and say I want a copy, and then put the angle to be 210. That's it with the axis lines. Now we'll have to go to the next step, which is building the outside shape. So I'll change to my thick lines layer, and I have here 150 millimeter diameter circle, 140 millimeter diameter circle, and 120 millimeter diameter circle. So circle here, diameter of 20, enter, tap enter, tap the add symbol and enter to have the same origin, D for diameter 40, and again tap enter to repeat the command, tap the add symbol to start from the origin point, D for diameter and 50. These are the projection of the 3 cylinders. And here we have 2 circles. One is 20 and one is 10 in diameter, because this is 5 here. So 5 from here and 5 from there. 20 minus 10, so that is 10. And then we have this one, which is a radius of 15. So we'll create it as a circle initially. So circle, diameter of, or rather radius of 15. Let's try that again. Circle, radius of 15. Okay. Now we have another circle, the same origin, and it has a diameter of 20. And we have another circle from the same origin with a diameter of 10. Those are the 3 circles. Now I have to copy them here as well. So copy, select the 3 circles, hold shift and deselect the axis, tap enter, click on the center, click here, because it's the same situation. Basically the shape is different, but the diameters are the same. So you have a 10 millimeter diameter for the inside. So you have 20 for the outer, and the radius here for the arc is 15. So it's the same situation. Now I need to build a line through here, and the easiest way I think is with the offset command, offset of 15, and I'll offset this axis here for the moment, and here, and here, and here. And now I'll trim like what I think it's the excess for this. I'll just have to clean up either by trimming or deleting the excess And now all I have to do is select these like that. This one should also be trimmed. And I'll move them to the thick lines layer. And I got my initial projection view. Have some leftover lines there. I also need to trim these arcs here because they are only arcs, they are not holes of their own. We'll have to start working on the front view, which will become our section view. So for that, we'll have to position it on top here because we're working in the European projection system. So for the moment, I will offset my axis by 60. There to denote like where the bottom of the part will be, the projection will be. And now I'll have to create a new layer, which is my helping layer, can be based on layer 0. So right away, and I'll turn it on. I'll make it red. Okay. And now I'll have to rotate these points of interest here. 1, 2, 3, 4, 5, based on this center on this line. So I can then project the corresponding view here once the section is done. So I'll give the arc command. The first point will be here. Then I want to select the center. And then the end point will be on the line. But the opposite way, and click. And again, arc, starting point here. The center point here. Hold Control and click on the axis. Again, starting point here. And the center here. Hold Control and click on the axis. One more time. Starting point is here. The center is this. Hold Control and click on the line. And one more time. Starting point is this one. Center. And hold Control. Click here. Now we have successfully rotated all of these points of interest. And now we'll project them we'll take them in correspondence to the front view here. So line, hold Shift to be straight and click. Double tap Enter. Next one, hold shift and click. Double tap enter. And we'll do this for all of the points here. And now I can also try to like project some of the other geometry. For example, this edge here. Goes like that. And this edge here. I am using the existing geometry to make it easier for myself to draw the front view, which will be a section view. So I think that's enough. I'll go back to the thick lines layer. And once I'm on the thick lines layer, I can see here that my thickness of the part, the first, like the smaller base plate is 20. So that means that I can start from here with a rectangle and end it here. And it has to be 20. So I can draw a helping line here. So line from here at 0, 20 and enter. And then a rectangle that starts from here and then ends in the end of that line. And this is my base shape. Okay. Now I will draw some lines that overlap with these. From here and perpendicular to this. Then another one from here, perpendicular to that. Another one from here, perpendicular to that. Another one from here, perpendicular to this. Then in this other side, from here to here. Here to here. From here to here. Okay, and then we have this other one from here to here. And this should be mirrored on the other side. So this thick line mirrored against this axis line. Tap enter. So we have the outer cylinder projection. And then the others are like we have here. So the larger one is 15, then the 50, then the other one is 40. So I can either come with the corresponding lines or offset by 5. I can do that by 5. 5 towards the right and 5 towards the left for this one. And this is 20 millimeters. And if this is 40, then I have to offset 10 from the left and 10 from the right. Offset 10. Here and here. Okay. And also I have to place an axis here, so I'll offset one of these lines by 5. Place an axis here. I will extend it by 3. 3. Also the same here. Offset by 5. And extended by 3 and 3. And now select both of these and move them to the proper layer. Okay. Now I can turn off my help layer because I finished drawing the corresponding lines. So I'll go here and turn off visibility. I have too many lines already. And let's concentrate here on the 3 big cylinders because they are of different heights. So the larger 50 diameter 50 millimeter cylinder and the 40 millimeter cylinder have a height of 35. So that means that here I have to extend these 2 lines and these 2 lines to have a height of 35. This one, because they already have 20, I'll just activate my ortho command to make sure I'll have this straight and go like that for another 15 on top of those 20. And this applies to that as well. 15. 15. And 15. And now I can also draw a line to join them like that. Okay, so this didn't have like placed it now the dimension and the inside diameter, which is 20, has a height of 25. So that means that we also have to extend these by 5. And here. And now we have to draw a line to join them together like that. And since we have these, now we can start removing some of the lines to fulfill our section. So I'll extend this line like that. And then I'll trim trim this line here and this line there. I'll have to continue trimming. So trim this one and this one. And also this one. And this one here. So let's continue trimming this line here and this line here, this one, and also this one and this one, like that, and this one here as well. So when we are looking at these cylinders, we have the outer cylinder, which is 50 millimeters. And then we have the inner cylinder, which is 40, but we don't see it, like we see only a bit of it. And then we have the 20 millimeter cylinder, which goes through. Okay. Now we have to create a new layer for the hatch pattern. Okay, make it active. Give the hatch command. Click here and here. And well, basically we have to do some more work. So only this part for the moment. And now we have to hatch edit this and set the scale to 15. As I said, this is countersunk, so we have to chamfer it by 5 millimeters. So that's why we need a chamfer angle 5:45, and click here and here. And now once again we have to draw that. So let me go to the thick lines layer to be there. Chamfer angle 5:45. Oh, we don't have the line, so line, enter, click here and there. Chamfer angle 5:45 here and here. Okay, and now we use the line command to join these together with lines. There it is. And also we don't need this line anymore, and nor this one. And in this case here, we can see that the depth of this is 5 millimeters. So we can use this line as an offset by 5. Offset it here. And then we have to trim around it. Oh, this got offset because it was a rectangle at first. So it's we have to explode this and then offset by 5. So not towards the top, but towards the bottom. Okay, and delete this one, and then trim here. We don't need this, and we don't need that one, nor this one, nor this one, nor this one. So this is the new projection that we are working with, and we can delete and redo the hatch pattern. So switch to the hatch layer here, give the hatch command, click here, 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 and here, and enter, and then hatch edit, and change the scale to 15 to have a nicer scale. Right, now that we have this, we can delete this line from here, and we can trim our axis a bit here and here and here and here and here and here. Let's extend a bit. 3. Okay. Extend this by 3 and extend this by 3. And extend this by 3. And let's also trim here. This one. And extend this by 3. This. Well, actually, this will become our trace. So we'll have to like let it be continuous here. Okay. And this one needs to also get like a bit extended, because we'll use it to dimension our angle here. It's easier to dimension the angle between these axis lines instead of between something else. Now we can move on to placing our section trace labels. So we'll move to the dimensions layer. And we'll create like a the symbol for the dimension. So here we have to extend this by another. Right, so I'll delete this axis line here for the moment and rotate this other one from here and make sure I create a copy, and I'll rotate it with 30 degrees just to make sure I have the center of the circle right. And then I'll have to trim the x-axis from here like that and delete this other one. Okay. And now I will build the symbol. So line, click here, then W, enter, 0.5, enter, 0.5, enter, at 10, 0, enter, W again, 1, then 0, then at 4, 0, then W again, 10, and 10 again, and at 0.5, 0, enter and enter to finish the command. Now I'll have to rotate this. So rotate this. Okay, from the middle of this with 90 degrees. I have my symbol here. Now I'll place my value. So M text, enter, click, H for height, 7, and click again, letter A, and move it next to the arrow here, like so. And now we can copy this like that. We can grab it by the middle of this line here and place it here onto our axis once. And then we can also rotate this here from the middle. So let's see if we can, we'll rotate it 30 millimeters, 30 degrees, sorry. Now we'll move it. Oh, and we can also move the, like we can mirror it so it will be on the other side. So select it, and then we'll click on this endpoint, and then on this arrowhead, and enter to have it on the other side. And we don't need this anymore. We can do it like that, and then move the newly created symbol by its midpoint here to the designated point, which is here. Now we have these two that designate our mixed dash dotted line that is supposed to be the cutting plane. And now here we have to label this. So we'll label this here. So M text, just about the middle here. And the height should be still 7. And we'll place here A minus A to denote the fact that I'm cutting through here and the resulting projection is this one. I can even go place it closer here. Once I'm finished with this, I can start with my dimensioning. So to start dimensioning, I have to give the dim style command and click on modify here or create a new one. And then I'll have to go to symbols here, and arrow size should be 3. Then I'll have to go to text. This should be 3.5. This should be above, should be aligned. This should be 0.5. Going to the fit tab. Here it should be both text and arrows. Place text manually, dimension between extension lines, and primary units, set the precision like that. This should be enough. Okay. And let me place my angle here. So DIMANG for angle. Click here and here. There's my angle. And now I'll have to dimension the part according to the dimension that I used here. So I can dimension this height here, DIMLIN, from here to here. There it is. Now I can also dimension these diameters. So DIM, LIN, because they are projected. And then I have to double click inside and write in %% to get the symbol for the diameter. And I'll do that here as well. And I can take this outside like that. %%C. And I have my there. Let me extend this as well by 3. And here by 3. And now I'll have to give these two diameters. I can give the diameters here, some of them. So let me give the larger one, DIM, DIA, enter. Click on this one. And as you can see, it places the symbol for me. I have to make sure I don't intersect anything. DIM, DIA, and click on the other one, this smaller diameter. Try to place it in here as well. Or maybe I can, if I overlap with this, I'll have to like cut a bit out of it. So to not get this too crowded, I will dimension this one here. Like that. And I'll place the symbol here like that. I have to dimension this chamfered edge here. So actually it's a leader, LEADER, leader. Then click here, then go at 10 less than sign 45, or let's do it on the other side. At 10 less than 135, like that. And then at -5, 0, and then 5 times 45 %D, and enter. And we have the chamfered edge there. We can dimension this 20mm diameter here. So DIMDIA, this one, and the smaller one as well. because I want to dimension the depth of this counter borehole. So from here to here, I want it to be 5, like that. And now I also have to dimension this part here. So from here to here, it's 25. And full height from here to here, I'll place it here, and I'll try to move this a bit closer so that I can also bring the 25 outside of the part. There it is. And I'll have to put this, make sure it doesn't intersect. I'll have to give the dimension again. So from here to here. And I'll leave it that way. So let's give this dimension, this linear dimension here. From here to here, 50. Should place also the radius here. DIM RAD, enter. Click on this arc. Place the radius. I should have like a title block here at the bottom. So rectangle, simplified version of this will be at 185, comma 0, rather comma 40. So once again rectangle, and at 185, comma 40. Okay, it should be thick. Right, and now I can use my block which I created earlier to specify a general surface finish here. So if you remember, the command created was surface block. There it is. And I'll place it here, so near that. There you go. And I don't want any scale nor rotation. And the value will be 12.5. And OK. And to denote the general roughness here, we need to complete this symbol. Now we can explode this part here. We don't need the value, and we can offset this value of 7 to the left and to the right. And now we can extend this like that and like that. And that there. There you go. And we can place one more surface finish symbol. So surface block, place it right here. Tap enter twice, 3 times. Place the value 6.3. Hit OK to finish.